Chapter 5 is looking at congruent triangles. And this first lesson in Chapter 5 is talking about the angles of a triangle. And so as we begin, we're going to look at our objectives and review how to classify triangles by their side and angle measures and look at common triangle notation. This lesson is also going to help us review triangle inequality theorems, and then we're going to focus on classifying a triangle in the coordinate plane and applying triangle angle theorems to find angle measures. So if you go to the top of your page that you've got there, you will notice that we have a properties review that we did last semester when we were looking at Engage in New York and just talking about the different types of triangles and how we need to look at classifying them not only by side measures or by angle measures, but by both. If you remember when we did this activity in the fall, we found out that there are 7 different types of triangles that are possible based on scaling acute, isosceles acute, equilateral acute, which are also called equiangular. With right triangles, they're either scaling right triangles or isosceles right triangles. It is not possible to have an equilateral right triangle. And then obtuse triangles would be scalene or isosceles because it's not possible to have an equilateral obtuse triangle. So these are the different ways that we name and identify triangles. And when you get into triangle theorems, such as the Pythagorean theorem or triangle inequality theorems, there's some common notation I just want to remind you of. No matter which of the 7 types of triangles you're looking at, in theory, angle A and line A are usually assumed to be the shortest. So, side A over here is across from angle A, they are the shortest, and line A is also called segment CB or segment BC, either way, as we're looking at the triangle. Angle B and side B are usually the medium-sized angles, assuming we have a scaling triangle. And angle B and side B are always across from each other. And side B can also be called segment AC because of the vertices of that segment of the triangle. Angle C and line C are usually considered the longest and the largest of the triangle. They are across from each other. And line C is also referred to as segment AB because of the vertices that serve the endpoints of this side of the triangle. So this notation, when you look at things like Pythagorean theorem that says c squared equals a squared plus b squared, or the triangle inequalities that we're fixing to review, if a triangle is scalene, this is kind of the common understood notation. If a triangle happens to be isosceles, it depends on whether the third side is shorter, longer, or even longer based upon the type of angle that's in each of these isosceles triangles, whether A and B are the 2 shortest sides or A and B are the 2 longest sides. So let's get into the next section, which is the triangle inequality theorems. And a question is often asked, if you have 3 segments, how do you know that you can make them into a triangle? If you're given 3 lengths, can you be sure that they're going to make a triangle? And the theorem we've looked at is that in any triangle, the sum of any 2 sides is greater than, right in your blank, greater than the length of the third side. The sum of any 2 sides cannot be equal to. And the reason for that is that if you have 2 sides that are equal to the third side, then they're going to collapse and not make a triangle. That the 2 sides, the shortest and the medium side, have to sum together to be greater than the third side for a triangle to exist. So when we're looking at that, considering the sides A, B, and C, there are 3 possibilities that we should consider as we're beginning to look at this. First of all, the sum of the two short sides, are they greater than the sum of the longest side? Secondly, the medium and the longest side, are their sum greater than the shortest side? And then finally, the shortest and the longest side, when you sum them together, are they greater than the length of the medium side? Well, two of these are pretty obvious. If you're comparing them to see if they're greater than the shortest side, obvious the medium and the long side summed together will be greater than that. So it's really not a big deal, other than we need to just consider it at the beginning. And the other equation, the short side, A, and sum to C, is it greater than the medium side? Well, since C is already greater than B, this is not something to consider. So the inequality that's most crucial is to see, if you take the two sides that are shortest, side A and B, and sum them together, will their sum be greater than C? And if so, then a triangle will actually exist. In part B here's an example. We're going to determine if these three numbers can form a triangle. So we're going to automatically look and see that A is 36, it's got to be the shortest. The next segment is 42, and the longest segment is 75. And we're going to see, if we had segments or boards this length or sticks this length, would we be able to lay them down and form a triangle? So we're checking to see, is the shortest segment summed to the medium segment going to be greater than the longest? And so we would add 36 plus 42 and see, is it really greater than 75? And when you add these two together, you find out that 78 is greater than 75. Therefore, yes, it's going to make a triangle. And so you're looking at the numbers, you just kind of consider these things. If the sums were 36 and 39, 36 and 39 sum to 75. And 75 is not greater than 75, so those segments, 36, 39, and 75, would not make a triangle. And determining that is just a matter of looking at the combination of those sides. So sometimes the idea comes up, well, I've got two segments. What is the range of numbers that could make the third side so that these three measures would indeed make a triangle? So we have to consider it, because it's a range, is what's the shortest that the length would have to be to make a triangle with 12 and 20, and what's the longest the length would have to be to make a triangle with 12 and 20. So to find the shortest, you look at the difference of the two. 12 taken from 20 gives us 8. So the length has to be greater than 8, and the longest, we sum them together, 20 plus 12 is 32, and so we know that for them to make a triangle, that the segment has to be less than 32. So writing it in notation, we would say that given two segments of 12 and 20, the third side would have to be greater than 8 and less than 32 for this to make a triangle. So let's look at this also and see if we can apply this to help us determine the longest and shortest angles and sides. So one thing you might look at is ordering the side lengths given the angle measures. We've got an angle of 50 degrees here. We've got an angle of 70 degrees there. So the two of them together equal 120. So subtracting that from 180, we find out that the third angle is 60 degrees. And now we can order from longest to shortest. Since 70 degrees is the largest angle, I'm going to go across the triangle and say the longest side is segment RP. 60 degrees is the medium-sized angle, so the medium-sized length is segment QP. And the shortest length is across from the shortest side, so segment RQ is the shortest. Sometimes you have to look from the greatest to the least. So if I'm looking here at 55 and 150, they add up to be 105. Subtract that from 180, and this angle right here is 75 degrees. So, the greatest segment, 75, is degree angle W is across from the greatest segment, which is segment XY. The medium size, angle X, is across from segment WY. And then the smallest angle, 50 degrees, is across from the shortest segment, WX. Of course, these questions could be reversed, where you have to read and write down from the shortest to the longest or the least to the greatest. You have to pay attention to what the instructions tell you. In Part B, it says to order the angle measures given the side lengths from the smallest to largest. So if I look here, my smallest side is 12, so that means it's directly across from angle Z. Angle Z is my smallest angle. My medium-sized angle is angle X because 22 is the number in the medium range, and X is across from it. And then my largest angle is angle Y because angle Y is across from the longest side, which is 25. So if I order these from smallest to largest, I have these three in this order. If I have to do it from greatest to least, well, my largest side is 13. So angle E is my greatest angle. 11 falls between 8 and 13, so 11 is my medium-sized angle, angle F, and then angle G is the smallest, or the least. So that would be the answer to doing those. So just thinking about this relationship, and that it's always going to be true, no matter which of the types of triangles we're working with, will help us as we're trying to order and understand things that we're looking at. So I'm going to stop this section for now, and then we'll go on to the next section in the next recording.